Welcome everyone. In this video lecture, we will solve a GATE 2021 question which is basically based on voltage gain calculation in PMOS transistor. Okay, so the very first thing is that the transistor M1 M2 is given in the saturation, which is already given, and the internal resistance of M1 and M2 transistor are R01 and R02 is given. Okay, and we have to ignore the body effect. Okay, and channel length modulation coefficient also we have to take ignore. So here we can say this M2 transistor and M1 both are PMOS. Okay, so for the gain calculation we have to draw the a small signal model. So before that I want to show you a very simple NMOS circuit. This one is gate, drain and source. Okay, when arrow signal is there in sub circuit, okay, that arrow signal always specify the source. Okay, so this region is our source and this one is also source, say S1, and this one is S2. Okay, so here this one is a NMOS. Okay, this one. So for this one I want to show you the first small signal model. So this one is gate, drain and source. This one will be our GM, VGS, and also add this resistance, say R0, and this voltage is VGS. Now for the PMOS, okay, so in PMOS arrow signal will be inward. Okay, so this one is again gate, this one is drain in and source in. Arrow signal shows the source in, so it should be plus and minus. Okay, so we are writing it VSG. So in this case we have to make this as a source, one gate in and drain in, and this will be the GM, VSG and R0, and this volt is nothing but simply VSG. V source terminal will be positive. In this case, that thing you have to know. This is the very basic concept. In this PMOS, the source voltage will be positive. Okay, but in case of this one NMOS, this GS. Okay, I have to write this one will be our VGS. So this gate voltage will be positive. So this one is the small signal model of PMOS. Now we have to encounter this question. But before that we have to know what is the small signal model of NMOS and PMOS. So if we know the circuit small signal equivalent model, then we can easily make this type of question. Okay, so first a small signal model. So for the small signal model we have to take it as a ground. Okay, or we have to remove it. Okay, for the small signal model. Then after what we have to do, so this one is our S2. Okay, S2. So then after there is a current in that direction, and it is nothing but simply GM2 VSG2. Okay, and we can add the R02 resistance here, and we have, for the small signal we have to make it ground, so the S2 terminal will be grounded. Okay, this all are S2 source terminal source. Okay, then it should be plus and minus, and this voltage is nothing but simply SG2. Okay, so say this one is our G2 in. Okay, get terminal, this one is G2. Okay, gate of 2. So now gate of 2 is connected to some supply voltage. So make it a signal source. So signal source, this one is V in. Okay, and this end is nothing but simply our D2, and this end we can say S1. So this one is D2, or simply say S2. D2 or S2 we can write, and we are taking output across this side. So we can say that one, this voltage will be V0. Okay, so this is all about the first transistor M1. Sorry, M2. Now we have to draw for the other one. So okay, now again the source is common to all. So for the time being, I am, this one is also S2. Okay, S1. Sorry, S1. This one is S1 already written, and this one is G1 and D1. Okay, so now the current will go like that, and this current is nothing but simply GM1 VSG1. Okay, and this is S1. Okay, one more gate terminal is there, that is our G1. Okay, and which is grounded, so make it grounded, and this voltage is nothing but simply VGS1. Okay, this in is our gate 1, and this one is nothing but D1, and there will be one, say, R not resistance, and it is connected to ground. So this one is the picture. Is it okay? So once again I want to repeat this thing. First thing, we have to make it this source one, then GM2 BS2 R02. Okay, D2 and S2 will be S D2 and S1. Sorry, this should be S1. There is a mistake. The S1. Now S1, say again there will be current go in that one. So this one GM2 with the transconductance. So GM1 VGS1 R not 1. Okay. So now we can say the current in this one R naught 2 is nothing but simply V naught by R naught 2. If some resistance is there, okay, one, it is grounded, and this voltage is V naught, and R naught 2 is there. So this current, say this current will be V by R naught 2. So this current is V naught by R naught 2, and this current will be V naught by R naught 1. So there are four current. So if we think about this point S1, so I am writing here. This point is say S1. So in this, okay, take this point as a S1. Okay. So this S1 point, what is the current? Say GM2 VSG2. Okay, and one current is going in that direction, upper direction. Okay, we can V naught by R naught 2, and one more current is going in that direction, that is our V naught by R1. Okay, and one more current, that is our, say, somehow this one I am writing for just for the this point. Okay, S1 point, then this current is nothing but simply GM1 VGS1. So now we have to write the KCL, Kirchhoff's current law. So if we write the Kirchhoff's current law, so total incoming current, that is our GM2 VSG2, okay, equals to, this one is the incoming at this point S1. Okay, and it is equals to V naught by R naught 2 by total outgoing, so R naught 1 plus GM1 VGS1. If you write this equation, then your 50% work is over. Okay, but after that again we have to think that our aim is to find the voltage gain. Okay, our aim is to find the voltage gain. Okay, so voltage gain means V output by V in we have to find. Okay, So now V naught is there. Okay, it's okay. Somehow okay, V naught is there. V out or V naught we can say. So V naught is there, but V in is still absent. So now we have to think about VGS1, VGS1 and VGS2. So VGS1 can be written as VG1 minus VS1. Okay, I am writing here. Now VG1 is grounded. Okay, VG1. So this voltage will be 0 and VS1. So VS1 is what? This one. VG1 is this one, and VS1 is minus V out. Okay. Now for VS2 minus VG2. Okay. So this one VS2 is how much? VS2. This one is grounded. Okay. So 0 minus V in. Okay. And this one is VGS1. VG. Okay. There is a mistake. It should be S times of G1. S times of G1. Okay. There is a mistake. Sorry. This VSG1. Okay, VSG1. We are writing in NMOS, it should be GS term. Okay, but here you have to write in PMOS S because S we have to make positive. So it should be VS1 minus VG1. So it should be VS1 is nothing but simply V out. So we can write it V naught minus VG1. VG1 is 0 volt. So should be V0. So we can simply say VSG2 is minus V in and VSG1 equals to V naught. Okay, this one is one more very fundamental concept. Okay, to solve this problem. Okay, this point is clear or not? There is a mistake. I have written for the N most type, but this one is P most, so we have to write SG. Okay, so now we take this equation. So I am writing this one. GM2 VSG2 equals to V naught by R naught 2 plus V naught by R naught 1 plus GM1 VSG1. Again I am writing. Okay, last time I made a mistake. Okay, so after that, again what we have to do? We have to write VSG2. VSG2 is minus, so we can write it GM2 V in, and this is a V naught by R naught 2 plus V naught by R naught 1, then plus VSG1 is nothing but simply V naught. So we can write it V naught. So this expression will be V naught 1 by R naught 1. We are taking common V naught plus 1 by R naught 2 plus GM, or we can write it 1 by GM. Is it okay? So up to this one is okay. So now we have two terms. We have to find V naught by V in. Okay, so it should be minus GM2, but GM2 by 1 by R naught 1 plus 1 by R naught 2 plus 1 upon 1 by GM we can write. Okay, so now this expression for the gain can be written as, okay, I have to because option is giving in terms of R naught 1 parallel. So okay, so we can write this one as R naught 2 plus R naught 1 into R naught 1 R naught 2 plus 1 upon 1 by GM. We are just R naught 2 plus. So this expression will be minus GM2, and this one means there are two resistance R1 and say R1 and R2. So if R1 parallel with R2, Its value should be R1 R2 by R1 plus R2. So it may be written as 1 by R naught 1 parallel with R naught 2 plus 1 upon Gm. We can write this one. Okay. Okay. So again I am writing the V naught by V in minus Gm2, and this all will be 1. Okay. Make it 1. Make it 1. There is a mistake. Means make it 1. Okay. Gm1 V1. Okay. Then after again we can write 1 by Gm1 plus R naught 1 parallel with R naught 2, then R naught 1 parallel with R naught 2 into one can write Gm. Okay. So this one is nothing but simply Gm2 divided by this can now R1 into R2 by R1 plus R2. So again this can be written as R naught 1 parallel with R naught 2 parallel with 1 by Gm, okay, by 1. Okay, once again I will write means this one Gm2, and this should be 1 by, because R1 plus R1 into R2 by R1 plus R2, so it should be 1 by R naught 1 parallel with R naught 2 parallel with 1 by Gm. So it should be minus Gm2, and this should be Gm1, and it should be R naught 1 parallel with R naught 2 parallel with 1 by Gm1. Okay, so the final expression I want to write. So V naught by V in is nothing but simply minus Gm2 R naught 1 parallel with R naught 2 parallel with 1 by Gm1. Okay, Gm1. So this one is the answer, final solution for the gain value. Okay. Okay, so this one is a GATE 2021 question. So this one is a multiple choice question, so I have forget to write the option. So for the this one options is given minus Gm2 R naught 1 parallel with R naught 2. Okay, the second option is minus Gm2 R naught 2 parallel with 1 by Gm1. Third option is, I am just writing because options was given, so it will better to write R not 2. Okay, and that D option is minus Gm2 1 by Gm1 parallel with R not 1 parallel with R not 2. So what should be the final answer for this one? So answer should be our D. Okay, so answer should be D. So this one is the gain calculation for this two PMOS circuit. Okay, so that thing we have to know the a small signal model for the circuit first. So that's why I have already written the I already draw the graph of NMOS, not graph, we can say the NMOS, a small signal model, better to write a small signal model. Sometimes in some book it is very, sometimes there will be confusion in writing, but go through this type of thing, means draw the circuit symbol, then current is like that, so like GMVSG. But in case of PMOS we have to make the source positive, okay, gate should be negative. Okay, so that's why plus minus VSG and write GMVSG. So remember in that manner, but in actual practice both the NMOS and PMOS having the same equivalent circuit, a small signal model, but try to think about in that manner. Okay, and go step by step. So first draw the equivalent circuit, a small signal equivalent circuit. So S2 GM2 VSG2 R02. Okay, then this should be S2, it should be D2 and S1. Okay, source of S1 M1 transistor, and G2 is connected to some input voltage, so V in S1 VGS1, and this one connected to ground, so GM1 VGS1. Now there are four current items, and this one current, this one outgoing current, and this one is also outgoing. So GM2 VGS2 equals to V naught by R naught 2 plus V naught by plus R naught 1 plus GM1 VSG1. Okay, so SG1, here I have made the mistake initially, but okay, I have corrected. So VSG2, VS2 minus VG2, VS2, S2 is source is connected to ground. For the SC model, we have to make the DC one to ground. So DC voltage source to ground, so it should be 0 minus VG2. G2 voltage V in, so minus V in, okay, minus V in. And similarly VSG1, VS1 minus VG1. VS1, that is source 1, is connected to V0, so V0 minus 0, so it should be V0. So in that manner, now we have to put this value. Okay, so we have put it the value in VGS1 and VGS2, then we can write, we get this expression. Okay, but in the question it is written in terms of parallel. This one is also correct, but we have to make it more simpler, so we have to write in that manner: V naught by V in minus GM2 1 by R naught 1 plus 1 by R naught 2 1 by, now this one is nothing but simply the parallel combination of two resistors, so it can be 1 by R naught 1 parallel with R naught 2. Now again similarly we can write R naught 1 parallel 1 by R naught 1 parallel with 1 by GM1. So it should be, our answer should be minus GM2, the overall voltage here. So this one is the answer. So this one is a very conceptual question. So we have to know the PMOS, a small signal model. So in that way we can proceed any small signal model based question. So thank you for watching, and also please subscribe my channel. Okay, thank you for watching.